Welcome to EC Elimu, Learning Simplified, and welcome to this lesson. In the previous lesson, we discussed a gold leaf electroscope, and we also looked at the major parts and the functions of each part of a gold leaf electroscope, right from the brass cap, the insulator, the metal rod, metal plate, the leaf itself, the metal casing, glass window, and even the earthing system. We also looked at how we can charge a gold leaf electroscope positively and negatively by induction and by contact process. And we also mentioned one of the uses, all of the functions of a gold leaf electroscope. And we said it's used to measure the amount of electric charges. Now in this lesson, we are going to look at the three other functions of a gold leaf electroscope, including determining the insulating property of materials, determining the quantity of charges in a material, and much more. My name is Albert. I hope you will enjoy the lesson. By the end of this lesson, I expect you to be able to describe how we can use a gold leaf electroscope to detect the presence of charge on a body. You can have two bodies, one is charged, the other one is not charged. Now, for you to distinguish which one is charged and which one is not charged, then we are going to use this gold leaf electroscope as we are going to discuss later. Again, I would like you to be able to explain how you can use a gold leaf electroscope to measure the insulating property of an object. You can have two bodies. One is an insulator, the other one is a good conductor of electricity. Now, for you to distinguish which one is an insulator and which one is a good conductor, then we can use this gold leaf electroscope. Another thing is that to explain how to measure the quantity or the amount of charge on a body. You can have bodies which are charged negatively. One has 3 electrons, the other one has 10 electrons. Now, how can you know which one has more electrons than the other? Then we are going to use this instrument we call a gold leaf electroscope. And then finally, I would like you to explain how you can test the sign of charge on a charged body. You can have two bodies, both of them are charged, but you don't know which one is negatively charged and which one is positively charged. Now, for you to identify the body which is positively charged and the one which is negatively charged, then we are going to discuss how you can use a gold leaf electroscope to determine that. We are going to begin with the first use of a gold leaf electroscope, and that is detecting the presence of a charge on a body. And for us to detect the presence of a charge on a body, it means we are going to determine whether a body is charged, either positively or negatively, or it is completely not charged. And for us to do that, then we need a neutral gold leaf electroscope. A neutral gold leaf electroscope means the leaf has not diverged, or the divergence of the leaf is 0. And if the leaf divergence is 0, it means the number of protons and the number of electrons in this gold leaf electroscope is equal. This one is a neutral gold leaf, neutral gold leaf electroscope. Now we are going to use this neutral gold leaf electroscope to determine whether a material is charged, either positively or negatively, or a material is completely not charged. Now, if you bring a material close to this gold leaf electroscope, if, for example, it is positively charged, let's say this material is positively charged, if you bring it close to the cap of this gold leaf electroscope, it's going to attract unlike charges, that is negative charges. So all negative charges will be attracted to the cap of this gold leaf electroscope, and then it's going to repel like charges. So it's going to repel all the protons down, and when the protons are repelled down, they will settle at the leaf and at the metal plate, and then there will be a repulsion between the leaf and the metal plate. So when you introduce a positively charged rod close to the neutral gold leaf electroscope, what you will observe is that the leaf will diverge. The leaf will diverge because the positively charged rod will attract the opposite charges, that's negatives, and it will repel like charges down. When the right charges have been repelled to the plate and the leaf and the plate will repel, and then divergency will take place. Now, if you also introduce a negatively charged rod close to the cap of a gold leaf electroscope, in this case, if you have a negatively charged rod, if you introduce a negatively charged rod here, what will happen? It will attract opposite charges. That is, it will attract protons or positives to the cap of this gold leaf electroscope. At the same time, it will repel similar charges, that is electrons, down to the leaf and the metal plate. And when they reach down there, they will repel. There will be a repulsion between the leaf and the metal plate. And also in this case, there will be a divergency. So divergence will take place either when a body is positively charged or it will take place when a body is negatively charged. It's because of the law of electrostatics, which states that when you introduce a body which close to the cap, it will attract unlike charges and it will repel like charges. But now, if you have a material, this is for charged bodies. The one that we have done is for charged bodies charged bodies. But now, if you introduce a material close to the cap of a gold leaf electroscope, which is neutral, and that material is not charged. When a material is not charged, it means the number of protons in that material is equal to the number of electrons in that material. Then, in this case, the leaf divergency will not deflect at all. So, if you introduce a body which is neutral, in this case, the body is also positively and it has equal number of protons and electrons. So in this case, there is no divergency. No divergency. When there's no divergency, then it means that the body is not charged. But whenever the body is either positively or negatively charged in either case, so long as the body is charged, the leaf will diverge. Now, the second use of a gold leaf electroscope is measuring the insulating property of an object. And to measure the insulating property of an object, it means we are going to use this gold leaf electroscope to determine which material is a good conductor of electricity and which material is an insulator. Also, we are going to use this gold leaf electroscope to determine which material is a better conductor of electricity than the other. For example, from your chemistry, you know aluminium has 3 electrons than magnesium. Therefore, aluminium is a better conductor of electricity than magnesium. But now, what instrument can you use to determine that? We are going to use a gold leaf electroscope. So for you to measure the insulating property of a material, first you need a charged gold leaf electroscope. Let's say we have a positively charged gold leaf electroscope like this. Now, if we have it positively charged, then it means the leaf already has diverged. Now, for us to determine now if a material is an insulator or a good conductor, then we will bring the material that we have in contact with the cap of this gold leaf electroscope. And then what we do, we will touch the material using a finger, or we connect a wire to the ground in what we call earthing. Now, when we have a charged electroscope and we put a material on top of that cap, and then we do earthing, if this material is a good conductor, then in this case, since we have more protons in the gold leaf than the electrons, therefore electrons will move from the ground and neutralize these protons. And if they move from the ground and neutralize these protons, if this material is a good conductor, then it's going to allow these electrons to come in and neutralize these electrons, and therefore divergency or the leaf divergence will fall. So if the leaf divergence falls when you put a material on top of a cap and touch it, then it means that material is a good conductor. So in this case, if it's a good conductor, what will happen? You will have your leaf, you will have your gold leaf like this one, and then this gold leaf, now in this case, divergency will fall. Then it means the number of protons will be equal to the number of electrons. And the reason why the number of protons become equal to the number of electrons is because the material that you had put up here is a good conductor, it will allow the electrons from the ground to move into the cup and neutralize the positives which are there. Therefore, leaf divergency falls. If you have a negatively charged gold leaf electroscope like this, and you want to determine the insulating property of a material or the conducting property of a material, remember this one is, let's say in this case now, it is negatively charged. When it is negatively charged like this, it means divergency is as risen. Then here, if you bring a material which you want to determine its conducting property, if the material is a good conductor and then you touch this material there to do what we call earthing, then if this material is a good conductor, it will allow electrons to move from the cup through this material to the ground. But if it does not allow this material or these electrons to move from the leaf, from the cup through the material to the ground, then it will be a poor conductor. But in this case, if it allows these electrons to move because it's a good conductor, then you will realize that the divergence of this leaf will fall. So if you see the leaf falling in either case, either when it's positively or negatively charged, then it means the material that you have in contact with the cup is a good conductor. And if the material that you have in contact with the cup is a poor conductor, then it means there will be no change in the leaf. So if it's an insulator, if it is an insulator, the leaf does not fall, does not fall. Then if it's a conductor, in either case, the leaf divergency falls. And again, now if you want to know which material is a better conductor than the other, then when you bring this material on top of the cup, if the leaf falls very fast, so let me just write note here, NB, if the leaf falls very fast, then it means that material is a better conductor. But if the leaf falls slowly, if the leaf falls slowly, then it means the material is a poor conductor, It conducts slowly. So in this case, for you to measure the insulating property, you have to have a charged gold leaf, and then you put a material on top of it, you touch using your finger. If the divergency falls, that material is charged. If the leaf does not fall, then it means it's an insulator. And again, if it falls very fast, that material is a better conductor because it allows electrons to move very fast. And if it diverges or it converges slowly, then it means it's a poor conductor because it allows few electrons to move into or out of the gold leaf electroscope. Now, the third use of a gold leaf electroscope is to detect or to measure the quantity of charge on a body. And for you to measure the quantity of charge on a body, then it means you need a neutral gold leaf electroscope like the one that we have on diagram 1 with 4 electrons and 4 protons. And now, if you have a body which is negatively charged but it has only 2 electrons, what will happen? These 2 electrons will attract 2 protons and it will repel these 2 electrons which are there on the cup. So the electrons will be repelled and the 2 protons will remain on the cup. Now when these 2 electrons will be repelled, remember down here it is neutral. These 2 are neutral. Then now when the 2 excess electrons have been repelled down, then now this leaf will diverge, but it will diverge because of the 2 electrons. Now we will have it looking like this. When we have now the positives, 2 of them on the cup, then we have down here 2 electrons have been repelled. Remember this positive and negative, they are neutral, they don't count. Then the rod that we are measuring its quantity of charge is up there, 2 electrons. Now this leaf divergency will rise due to resistance or due to repulsion between the leaf and the plate. So in this case, the leaf will diverge slightly because of the two electrons. But now, if you have the same negative or neutral charged or neutral gold leaf electroscope like this, which has 4 protons and 4 electrons like this, and then now you introduce a body which has more negative charges. Let's say they have 4 of them close but not touching the cap of this gold leaf electroscope. What will happen? These 4 electrons will need 4 protons to attract to this cap. So it will attract the protons which are down here to the cap. So in this case, the positives will be attracted to the cap, and then it will repel the electrons which are at the cap down up there. So this one will be repelled. So when now the positives will be attracted to the cap, 2 of them, and then the 4 electrons will be repelled, then now we will have a gold leaf electroscope which looks like this. We will have the cap there. Now it had 2 protons and 2 of them have been attracted, so there will be 4. Then this rod which you want to test its amount of charge will be here with 4 electrons, and then now this we have a metal rod there, and then we will have the electrons which have been repelled, but in this case they are more. They are more. They are not 2 like in the first case. They are more. So in this case there will be electrons there, 2 of them and 2 of them. Now when they have 4 electrons, in this case 2 repelling 2, the repulsion will be very great. Therefore the angle here will be very large than the initial angle there. Now when the divergency rises more, then it means the body which you introduced has more electrons. Now when the divergency is small, it means the body that you introduced has less charges. So here it's important to note that more divergency, it means there is more charges. There is more charges. Less divergency, it means there is less charges. So the fourth use of a gold leaf electroscope is testing the sign of a charge on a charged body. Now for you to detect the sign of a charge on a charged body, then you need an electroscope which is charged. Like in this case, let's say you have a positively charged gold leaf electroscope. So you will charge an electroscope and you will know the charge that you have made on that gold leaf electroscope. Let's say you charge it positively like this. Then now what you do, you will introduce a charging or a charged material which you don't know it is charged. So here you don't know the charge which is there. Now if divergency of this positively charged electroscope increases, if the divergency increases, then it means the charge on this body is same as the charge of this gold leaf electroscope. So here it will mean that this body was positively charged. So if divergency increases, then the body has the same charge as the gold leaf which you charged positively. The reason why it will have the same charge is because when you introduce a positively charged leaf, it will repel these protons which are on the cap. When protons are repelled, more of them will move down and they will repel between the plate and the leaf. Again, let's say you have a gold leaf which is negatively charged. It's negatively charged. Then now you introduce, it's negatively charged like this. Then you introduce a body which you don't know it is charged. Then again, the leaf divergency rises. It rises from its initial position to new position here. Then it means when the divergence increases, it means now this body is also negatively charged in such a way that when you brought it close to the cap, it will repel more electrons. When more electrons have been repelled, they will move down, and then there will be a repulsion between the plate and the leaf, and that's why the leaf will increase or the leaf will diverge more. But now, if you have a gold leaf electroscope, let's say you have it positively charged like this, positively charged gold leaf electroscope. If you bring a material which you don't know it is charged, and then instead of the leaf diverging, the leaf falls. Let's say you bring a material which you don't know it is charged, and then now when you bring it close, the leaf falls, divergence falls from its initial position to a new position here. So the leaf falls. Then it means here the material that you brought here has an opposite charge like the charge on this leaf. So it means this one is negatively charged like that. The reason why it's negatively charged, it means when you bring it close to the cap, it will attract some of the protons to move up to the cap. When they move up to the cap, the number of electrons or the number of positives which are on the leaf and the plate will decrease, and therefore there will be a small electrostatic force. Therefore, the leaf divergency falls. And if you have it as a negatively charged, if you charge an electroscope negatively like this, and then you introduce a body here which you don't know it is charged, you don't know it's charged, and then when you bring it close, divergency falls. If divergency falls from its initial position to our new position here, it means the body that you brought has opposite charge like the one on the gold leaf electroscope. The reason is when you bring it, if it is oppositely charged, it will attract some of the electrons to this cap, and if the electrons have been attracted, we will remain with less electrons on the leaf and the plate, and therefore there will be a small electrostatic force. Therefore, the leaf divergency will fall. So that marks the end of our lesson today. In the next lesson, we will discuss application of electrostatics.